Running 12 volt equipment is a no-brainer with 12 volt batteries, but what about 240 volt AC gear? You need an inverter, one of these things, which changes 12 volt DC input to 240 volt AC output. There are a few different types of inverters, modified sine wave and pure sine wave. Out of these, it's the pure sine wave inverter you want for a 12 volt RV power setup. Pure sine wave inverters smooth out any voltage spikes and can run sensitive electronic gear like laptops without damaging them. Pure sine wave inverters have the same output as your 240 volt socket at home, so equipment will also run more efficiently. Unless you're only free camping for a couple of days at a time, those U-Butte house batteries are going to need to be charged up. At the most basic level, a 240 volt to 12 volt charger is the way to go. As a rule of thumb, for a 100 amp hour battery, a 25 amp charger should be fine. Or for 2 or more batteries, go for a 40 amp charger. Just be aware that you can't dust off your old charger you bought 20 years ago and use it with AGM or lithium batteries. Each one needs a specific charge profile and they must be wired up as close as possible to the house batteries to avoid voltage drop. Using such a charger is fine if you have 240 volt mains power or a generator handy, but if you don't, you still have a couple of good charging options. One way to charge your house batteries is using your tow vehicle's alternator. With the engine running, the alternator provides power to run through a DC to DC charger in the RV and then to the house battery. Most newer vehicles have what's called a smart alternator system, which allows the vehicle to control the output voltage from the alternator based on vehicle operating conditions to reduce electrical load. This type of alternator doesn't do a great job of charging a house battery due to the varying voltage of the alternator. This type of alternator doesn't do a great job of charging a house battery due to the varying voltage of the alternator. To get around this, you'll need one of these, a DC to DC charger. A good DC to DC charger will fully charge the RV's house battery whether the vehicle has an old school fixed voltage alternator or a newer smart alternator. A good DC to DC charger will draw current from the alternator and bring a discharged house battery up to 100% using battery specific 3-stage charge profiles. The DC to DC charger should be mounted as close as possible to the house battery to avoid voltage drop. To charge a caravan's house battery from a vehicle's alternator, you need to run a minimum of 6mm squared cable and also use a 50 amp Anderson plug to connect the wires at the tow bar. If you don't, you'll have too much voltage drop, which will reduce the amount of charge going into your house battery. You'll need a good quality inline MIDI fuse or a resettable circuit breaker, and it is a good idea to fit a relay so that the plug is only powered when the vehicle is switched on. That's so if you leave the caravan accessories like a fridge on and forget to unplug the vehicle overnight, for example, you won't run the vehicle battery flat. Although a good DC to DC charger will actually isolate the vehicle and house batteries. Now, the El Cheapo way of making power at camp is to kick your car over and make your alternator charge your system up. But that burns fuel and it also makes noise, and it could also make for a pretty uncomfortable camping experience as you pee off your neighbours. For years, a portable generator has been the go-to 240 volt power source when it comes to bush camping. Generators come with different output ratings, so choosing the one you need depends on how you use it. Jennies are rated in kilovolt amps, but you want to convert that into watts to figure out what equipment the Jenny will comfortably power. Electrical gear draws a certain amount of power, but rarely consumes all the power they draw. The difference is known as the power factor. Getting the exact power factor for each appliance is difficult, so as a rule of thumb, let's assume a power factor of 0.8 for all electrical loads. So in this case, a 2 kVA Jenny spits out about 1600 watts. The catch is that a generator's quoted power is for its peak rating, which it can only sustain for a short time. You have to dig out its continuous rating specification, which is usually about 80% of its peak rating. A small generator like this one can also run low current draw items like a small fridge, TV and RV lights. If you want to run a 240 volt air conditioner or a big 240 volt fridge at camp, it gets a bit tricky. When an electrical motor powers up, it can draw a lot more current than it needs once running. So for example, a 1400 watt air conditioner may need up to 4,800 watts to start it. The best aircon units have what's called a soft start, which basically lowers the amount of power needed to get the motor spinning. In any case, a 2.4 kVA generator like this one should run an air conditioner, no worries, in all sorts of temperatures. Whatever Jenny you choose, make sure it's the sine wave inverter type. These generators filter the output to deliver smooth power that won't damage delicate electronics. Just like using your vehicle alternator to charge up house batteries, a generator makes noise. Although modern ones like this one are really quiet. When you're using them in a camp situation, try and position the generator as close as possible to your campsite so that you're not actually affecting other campers. Likewise, you can run one lead to get it right away from everyone's camp. Of course, it's worth remembering that Jennies need fuel and maintenance, and add at least 20 kilos to your RV's payload, including fuel. Generators are mostly permitted for use in national parks, but with restrictions. It's best to check with your national park before you go.